This is 8th grade, lesson 7 for module 7. And now we're going to continue working with those infinite decimals. So let's go ahead and start with this opening exercise. Expanded form is exactly how it sounds, that we're going to put something expanded, which means we're going to stretch it out. Okay, so we have this decimal here, 0.3765, and we're going to use powers of 10 for that. Now, this last lesson we did powers of 10, but they were in fraction form. So now we're kind of going in reverse. Now I'm giving you the decimal. How can you find the fraction form? So we're going to start by saying our first number is a 3. So we're going to put 3 over 10 because it's in the tens place. Next one, we're going to say plus 7 over 10 squared. Well, what is 10 squared? It's 100, and the 7's in the hundreds place. Plus 6 over 10 to the third, plus 5 over 10 to the fourth. Okay, and of course we can keep going on if the decimal kept going on, but that's your answer in expanded form. We took this decimal and expanded it out. All right. You could say in the end, it's 3765 over 10 to the fourth, but we're not really looking for that right now. The final answer at this stage in the game, the opening exercise, is just to leave it like that. Let's do the next one. We have a repeat decimal. Now, repeat decimals are a little different because they don't terminate. They're never ending. But we can still do some. So we're going to do 3 over 10 plus 3 over 10 squared plus 3 over 10 to the third, plus 3 over 10 to the fourth, plus 3 over 10 to the fifth. And you can keep doing this forever, but we're not going to. We're just going to give it a little dot, dot, dot. And that's all they want right now. Same thing with the repeat nines, okay? But this one has a question first before we really dive into it. Have you ever wondered about the value of 0.99999 repeating? Some people say it's infinite decimal, and it has a value of 1. Some disagree. What do you think? So some people think it's infinite, which it does go on forever, and its decimal has a value of 1. So they're saying that this whole thing would equal 1, but some people disagree. So I'm going to give you a second, write down your own opinion. What do you think about this number here? Now we're going to look at this tree representation here of these decimals being broken down. And at first it looks a little kind of, I don't know, confusing. Can we say that? But it's actually not too bad. Let me see if I can kind of clear up some confusion. So we have this decimal here, which is 0.253. Now we know the 2 is in the tens place, so that's going to be 2 over 10. Plus 5 is in the hundreds place, so we're going to say over 100. And I'm writing it out this time instead of using 10 squared. And we're going to say 3 over 1,000. All right. So what we're going to do is we're going to place these as they've already placed them here on this number line. I'm going to explain to you how to use this. So your first number is a 2. So if this is 0, this is 0.1, this is 0.2. So that's why they put that there. So now when I start the next number line, what we're basically doing is trying to narrow the gap down, okay? So now this number is going to come straight down and be the beginning of this number line. And this very next number, if this is 0.1, that's 0.2. This one here is 0.3, which is going to be the end of this. So what am I actually looking at here? What did they expand? This whole number line here is this little piece right here. So they took this little bitty piece of the number line and blew it out, okay? And that's because it's very hard to put that number on a number line because it's so small, all right? That's what they're trying to help us out here, is just making it bigger. Now, we have the next number is being a 5, all right? So we have 0.1, 0.2, 0.3, 0.4, 0.5. So we bring down the 0.2, and now it's 5 because we're starting at 0.2. So this would be 0.21, 0.22, 0.23, 0.24, 0.25, and that's where that dot goes then. And then we have our last number, which is a 3. Okay, so again, this is the beginning of our next one. And this being 0.26 is the end of this number line. So again, we're getting smaller. This here is what we're looking at down here. So this is 0.251, 0.252, 0.253. So that's where that would be marked on a number line. So that's how we kind of use this to help us here. So our final answer here is we're going to go ahead and just combine all those numbers. We're going to say 253 over 10 to the third power, because 1,000 would be 10 to the third power. And you can also say 253 over 1,000. So imagine having to place that on a number line. We're talking a very, very, very small fractional answer. And that's why they had to keep blowing out the number line, or we'd really be trying to guess where they were on these number lines. All right, let's try the next one. Now this one has a bigger tree breakdown, and that's because the number is repeating. And then when the numbers keep repeating, so does the tree breakdown. It'll keep going and going and going for infinite time. Okay, now when you take 5, 6 and you divide it out, that's what you get. You get this 0.8, and the 3 keeps repeating. All right, so what we can do is start writing this up. We can say 8 over 10 plus 3 over 100 plus 3 over 1,000 plus 3 over 10,000, and it goes on forever. Okay? Now let's break these into powers. So this would be 8 over 10 to the first, plus 3 over 10 to the second, plus 3 over 10 to the third, plus 3 over 10 to the fourth. And again, this can go on forever. So let's look at the tree diagram here and see how they broke this down. So they went over 8 dots to get it to right here. So this is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8. And again, 0.8 is now the first number over here. And this being 0.9 is now the last number. My next number is 3. So that's 0.81, 0.82, 0.83, and we're done. So 0.83 becomes the beginning number of that number line. And this being the next one in line is 0.84. That becomes the end. So now we're going to do 0.83 again. And you'll notice here that because now we're repeating the 3s, we're staying right there in that 3s column for all of these. Okay? So where before you might jag back and forth depending on what the next number was. If it was 5, you'd go over 5. If it was over 2, you'd only go over 2. But now because they're all repeat 3s, they're staying right on that number breakdown. So our final answer for this one here is going to be that we have 8, 3, 3, 3, 3. Of course, it keeps going. And let's say 10 to the 5th power, because that's 1, 2, 3, 4, 5. So 10 to the 5th. And we just put and so on. Okay, you could also put the infinite. Oh, that didn't quite come out right. There we go. Try that again because that's not quite infinite. That's the infinite symbol. Infinite means when you see that symbol means that number keeps going on forever. All right, let's try the next one. On to the back. So now we're going to take these ones on the back and start building our own tree breakdown. So they gave us some blank number lines and we're going to break them down on our own. So the first thing we were going to do is spread out that 0.125. So we're going to say 1 to the 10th plus 2. And now you don't need to write the 10, hundreds, thousands anymore. If you're comfortable going straight to the powers of 10, you can. So this would be 2 over 10 squared plus 5 over 10 to the third power. Now let's start building our diagram here. So our first number is a 1. So that would be 0.1 right there. Now 0.1 will now be the beginning of my next number line. And this is 0.2, which is the very next one. So 0.2 will be over here. Now my next number is 1, 2. So this is 0.11, 0.12. So we're going to go there. We're going to say 0.12. Now 0.12 will be the beginning of this number line, and this being 0.13 will be the end of that number line. And then finally we have a 5. So we're going to count 5 spaces over. 1, 2, 3, 4, 5. This is 0.125. And you're done. That's it. All right. You guys are going to do numbers 2 and numbers 3 on your own. And then on the back of that, on your third page, so I'm going to clear this for a second. So you're going to go ahead and do 2 and 3. Okay, finish those up. They're just like building those breakdown factor trees that we just did. And 4 is as well. Number 5, I just kind of want to explain here. We have 2 repeats. All right, so I want to kind of go over number 5A with you real quick. You'll notice you have a whole number. That whole number comes out in front of all those fractions we're going to make. So my next one is 1, and the 1 is in the tens place. And then followed by that is a 2, and the 2 is in the 10 squareds place. And then the next number is a 1, and that goes in the 10 to the thirds place. Okay, so I've done that one, and that one. So now we're at a 2 again. Okay, and you'll start to notice what keeps repeating here. The 1, 2, 1, 2, 1, 2. Okay, so this is how they wanted you to write it up in expanded form from least to greatest. Okay, so just go ahead and starting with the least number, work your way up to the greatest value. All right, and then 2 is in front of that just because it is 2 as a whole number. And then this one here is explain how you knew the order to put them in. And this will be just your own statement here. All right, so this concludes this tutorial.